All right, so I've been asked by a number of you to start to discuss the digestive system and what is the pathway through the digestive system. So I'm going to start with a basic overview and then kind of break the structures down individually. So of course you know that food starts in the mouth. And then from there it goes down the esophagus to the stomach, and that's through the cardiac sphincter, also known as the lower esophageal sphincter. Then from the stomach, it goes into the small intestine, which is split up into the duodenum, jejunum, and the ileum. And then from there to the large intestine, which ends in the rectum and the anus. So we need to think about what each of these structures is doing in terms of digestion. For their function, the mouth is involved in what we call mechanical digestion because of chewing. Now, it also has some chemical digestion because of the salivary amylase that is released in the saliva. When we go to the stomach also has a mechanical function, which is the longitudinal, circular, and the transverse muscles. And it has a chemical way of breaking down food too, with acid and pepsin, which breaks down proteins. And remember that the acid activates the pepsin. When we get to the small intestine, there are going to be more enzymes present, and the enzymes that are present are going to be from accessory organs. And those are going to continue to break down the food. By this point, the mechanical digestion is done. And the large intestine is going to be, so the big job of the small intestine is going to be absorption. And the big job of the large intestine is to absorb predominantly water and ions. Okay, so now that we've got this basic framework, we're going to talk about what is in each structure that enables it to do these functions. Okay. First, in your mouth, you have teeth, and these will be doing the mechanical breakdown of food. Breakdown. And you have salivary glands. And these are the parotid, submandibular, and sublingual. The job of these salivary glands is to release fluid and amylase. And the amylase is going to start breaking down that food. So now food heads down the esophagus and it gets to the stomach. And in the stomach, we have several different kinds of cells. There are the parietal cells, These secrete acid. There are the chief cells. Those secrete pepsinogen, which when combined with the acid becomes pepsin. There are G cells, which secrete gastrin, which increases stomach motility and acid production. And there are mucus neck cells. And these secrete protective mucus. Now, remember that the job of the stomach is going to be both to chemically and mechanically break down food. And the way it's going to do that is by using this increase in motility. So this is mechanical breakdown. And these chemicals. That's chemical breakdown. But here's the thing. We don't want this stuff to be active all the time, because if it is, then our stomach is going to be constantly moving and constantly secreting acid, and it has a ability to digest itself. So we actually need hormones to trigger the increased stomach motility and increased stomach secretions. Now that's where the small intestine comes into play. So when acid reaches the duodenum, it triggers the release of GIP, which inhibits gastrin. Now the stomach will be less mobile. But we also want to decrease acid, and to do that, we release secretin, which decreases the activity of the parietal cells. There we go. So this basically tells the stomach, hey, it's time for you to chill out. You're not digesting anymore. Now this stuff has made its way into the intestine, and it lets the stomach relax. Now, the rest of the small intestine is really concerned with the absorption of material. And if you were to look at its structure, what you would see is you'd see inside of the intestine there are waves like this, and these are called intestinal fold. And it's really long, and both of these things increase the surface area, and they also slow down the movement of food through it. The next thing you'd see is if you looked closer at these intestinal folds, I'm just going to pull a little area of that out, you'd see that the folds themselves have these sort of little finger-like projections. These are called villi. And these increase the surface area so that food molecules that are coming close to the intestine have more spaces to interact with and hopefully absorb. Then, if you look at those villi even closer, what you see is that the individual cells on the villi have these little cilia on them. Those are called microvilli. And this again gives them even more surface area to absorb food particles that happen to come in contact with them. There also is going to be some release of enzyme from these cells in the villi, and as the enzyme surrounds the food particles, it will be able to break it down into smaller and smaller particles. So really and truly, the small intestine is built for absorption. Now, in the small intestine, there's going to be some enzyme, but what you'll notice is that I haven't really listed a lot of enzyme creation that's happening in the small intestine. Most of that's coming from accessory organs. And the accessory organs we haven't even listed yet. These are the pancreas, the gallbladder, and the liver. And the gallbladder, the liver gives the gallbladder bile, which the gallbladder concentrates, and the gallbladder will release concentrated bile into the duodenum, when fat is sensed. That sensing of fat causes a release of CCK, cholecystokinin. And cholecystokinin causes this contraction, releasing that bile. The bile is going to break the fats up into really small globs so that they can be broken down by enzymes. So what's the pancreas doing? Well, the pancreas, in addition to its role with glucose with glucagon and insulin, it is going to release enzymes and bicarbonate. The bicarbonate is actually going to be involved in neutralizing the acid that's already in the duodenum. Why does it need to do that? Well, we stopped acid production in the stomach, but we didn't get rid of the acid that's in the duodenum, and the enzymes that are in there are not going to be able to work at the low pH that the stomach had. Now, this squeezing of the pancreas, or this release of stuff from the pancreas, is caused by both the fat, or the secretin, and the CCK. So they're what's going to lead to this. I know it's a little bit messy, but hopefully what you're realizing is that this combination of a low pH and fat is causing the release of chemicals which can be used to neutralize the pH and to digest the fat. Meanwhile, when the pancreas is activated, it is also going to release somatostatin. And somatostatin inhibits gastrin secretion. Why is it doing that? Well, again, the stomach does not need to keep secreting acid. It does not need to keep moving because the food has made it to the duodenum. It's already made it past the stomach. So the stomach is kind of done. And it gets multiple cues telling it it's done. Once we get past that duodenum, now we've got all these enzymes, the pH is proper, and there's going to be continued digestion of food into its chemical molecules and absorption into that small intestine. Remember that the small intestine is vascular. There will be a capillary that runs up into this villus and will pick up the absorbed nutrients and take them back into the bloodstream. Now, an interesting thing happens when the nutrients head into the bloodstream, and that's that their first stop is not the heart. They actually are going to stop over here at the liver to clean. So the blood that goes through the intestine is going to go to the liver, it's going to be cleaned, and then it can head to the heart where it'll get pumped back out to the system. Okay, so now we've done all this absorption of nutrients, and then we get to the large intestine. The large intestine has a similar structure to the small intestine, and what's going to happen in the large intestine is typically absorption of water and ions. And then the large intestine is going to be involved in compaction of the feces to prepare it for exiting the body.